Hi, my name is Gareth Burley. I'm with a company called Microcare. We are manufacturers of solar equipment, and in fact, this year we're celebrating 35 years of manufacturing here in South Africa. And today I'm really excited to introduce you to our range of electric vehicle chargers. Microcare started delving into EV chargers back in 2017. We've progressed into today. What I'm presenting to you is our latest invention, a DC to DC charger in a 12.5 kilowatt module and a 50 kilowatt module as well. So Microcare has been going for 35 years now, and over the years we've been growing and learning a little bit about the industry and looking forward to introducing a proudly South African product into the market. And I think as the shift to electric mobility accelerates, Microcare has proudly expanded this to cutting-edge range of EV chargers designed with both performance and convenience in mind. These combine smart technology, robust engineering, to deliver fast, reliable charging across a wide variety of electric vehicles. And this could be for home, commercial, or industrial use. EV solutions are built to power the future. I mentioned our first engagement was back in 2017. We built a 8 kilowatt vehicle to grid charger in partnership with a Nissan Leaf. Then we, together with Ohilo, developed a 50 kilowatt AC/DC fast charger, which we have in our factory. And this was a fantastic opportunity for us to really learn about EV charging. We then modified our learnings into integrating it into our standard product range. So our 10 and 15 kilowatt inverters could have standard electric vehicle charging in them. Then we developed a 32 amp multi-station AC charger, which we have outside of our factory. These are standard AC chargers. You can have up to, well, we currently have 5 outside of our offices, but you can have many more, so ideal for shopping centers. And then our newest initiative is the 50 kilowatt DC fast charger, which I'd like to present to you today. So a couple of features about this fast charger. It's got an input panel voltage between 700 and 1000 volts. Essentially, we're taking PV directly into this charger. Its output is up to 50 kilowatts, but we have built them into 12.5 kilowatt modules, so you could go 25 and so on. It has input and output protection, current limiting, as well as data logging, Wi-Fi integration as well. There are many programmable features, very high efficiency because we're using direct PV power into the car, and it has got the advanced constant power point algorithms that we use as well. So here's a little bit about our 50 kilowatt DC to DC fast EV charger. Remember, direct solar to vehicle charging. So it's fully solar powered. That means we can avoid the heavy costs of grid interaction and integration, as well as a big battery bank. Very high efficiency. Of course, it does have a variable speed charger. It has all the integration of Wi-Fi app and interactivity with it. And currently it's sitting at a 50 kilowatt max charge, and that's the current unit that we have. So essentially the solar panel network would then plug directly into our DC charger and then directly into the car. So this avoids then having to invert from DC to AC back to DC and so on. So very efficient and very economical. The smallest PV array was about 10 kilowatts. Of course, the more PV you have, the faster you can charge. And currently, as mentioned, 12.5 kilowatt modules. We have a 50 kilowatt, but the possibilities are there for us to expand even greater. And very fast charging. Obviously, every car is different, so different length of time, but we're looking well under an hour here charging for cars, sometimes much quicker than 30 minutes. With the sun present and the car connected, the PV supplies directly into the EV charger and then charges the car, the bus, the excavator, the mining equipment, whatever it may be. When the sun is present and there's no car connected, the PV supplies power to the EV charger. And then we are now integrating battery storage into that so that there's no wastage of that power. And then the battery then, of course, can supply power to the charger and then which charges the car. So we have a couple of applications here, but primarily what we're focusing on is trying to eliminate the need for the grid integration. And this really can reduce costs. If you consider a petrol station owner who wants to include EV charging, for him to go and put up a 50 kilowatt fast charger, it's going to really push up his maximum demand charge. So this is a game changer. It also means that you could put EV charging in any location. Think about buses coming along on a route, or in the mining or farms, excavators, tractors, and so on. So it really is an endless option. It's proudly South African. We've designed and developed it right here in Nelson Mandela Bay. And I know there's many that are claiming to be the world's first. We believe it's the first above 12 kilowatts. We're aware of 1 or 2 others that have been designed and developed at huge costs, but we're very proud of this South African story. And we're glad to be contributing some really green technology into the South African market. So here's my contact details. I'd love for you to engage with us and find out a little bit more about our locally manufactured EV chargers, but our very first DC to DC charger, which is available now. Please do contact me. Contact details are available on the screen. Thank you for your time.